Now this is our next question. We received this from one of our supporters. Now let's talk about synthetic division and what are the necessary items to be considered in doing the said process. Math in question. Think. Inquire. This is MATHinQ. Answered questions. The question is stated in general form, so we're going to attack this in general sense. We might not be able to give exact examples, but we're going to look into the considerations into the synthetic division. In vernacular, usahay, dili mao akong answer kung synthetic division. Unsa ang angay nako bantayanan. In short, we are asked about the things to be aware of or to be cautious about when we are trying to solve the quotient of two polynomial functions or polynomials using synthetic division. So to start, of course, we are going to establish first what synthetic division is. Say, for example, if this is your dividend, you're dividing polynomials or polynomial functions. Your dividend will be expressed in this manner: a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus until you reach a sub 1x plus a sub 0. This could take any form. So for example, if these are all zeros, then you will have a linear function or linear form of a polynomial. But of course, in general sense, that's what we have. And then our general form of divisor is also identified as x minus c. Now for synthetic division, we usually do this. We simply list all the coefficients, only the numerical coefficients, okay? And we operate it with a certain c that is taken from your divisor. And the process involved in that is actually this one here. You bring down a sub n, then you multiply a sub n with the c, so a sub n c, and then you add, then you will get a result here, doing the same process until you reach this last portion here. So this is synthetic division. Now, let's talk about what are the things you need to consider whenever you are going to use synthetic division to get the quotient of two polynomials. Number one, let's look at your dividend. Okay. The first thing you need to consider in your dividend is whether it is already arranged properly or its arrangement of terms. Let's look at the general form or dividend. It should be arranged in this manner, in decreasing order of the exponents of your single variable x. We know here our first exponent is n rather, then the next is n minus 1 until you reach here x to the power of 1 and your constant with actually x to the power of 0. It should be arranged in that manner, because if it's not, then the coefficients that you are going to use here in the synthetic division may be rearranged as well. Hence, you will get an incorrect solution or incorrect quotient. Okay? That should be considered. So I'd simply arrange them into decreasing order of the exponent of your variable, in this case, x. The second thing you need to be aware of in your dividend is this: the completeness of your dividend. We're talking about whether or not there are complete or there are no lacking terms. Say, for example, I told you I'm not going to give you a singular example, but let me just give you one example for the illustration. X cubed plus 1, that's your dividend. When you write the first step of your synthetic division, as you write the coefficients, do not write 1 and then 1 and then your c there. This is an example of an incomplete polynomial dividend, because we are expected that if we're going to write our synthetic division, we need to make sure that the necessary terms here should also have representation. So it's not 1 and 1, because we don't have here x squared, we also don't have x. So to correct that, our entries of our dividend for synthetic division should be 1 for x cubed, 0 for x squared, because 0 times x squared is just 0, 0x, and then your constant 1. This should be considered as part of your coefficients in your synthetic division, because if you left that one out, then your answer later on will be incorrect. This is also true. Say, for example, you also have another example here. Let's say x to the power of 4 minus x squared plus 10. So for x to the power of 4, you have 1. For your x cube, you don't have x cube. your x squared has negative 1. You don't have x. And your constant is 10. So if there are missing terms, supply rather the process of your selective division with zeros to correspond with their placement. Again, it follows after the correct arrangement of your terms. Before we continue, we would like to emphasize that you can join us on our social media platforms. On our YouTube channel, please subscribe. You can also follow us on our TikTok account. And of course, for more information, follow us on our Facebook page. So let's continue. For our second part, you're going to look at your the correct value of your C. This is actually very important, as this is the multiplier you need to do, or you need to use for your synthetic division here in general. How do we get C? Simply look at your divisor x minus C. Simply equate it to 0, and then when you solve for x, that should be the value of your C. This is in general form x minus C, because if it is x minus 2, definitely when you equate it to 0, your x is 2. But it's different if you have x plus 1 equate to 0, your C is not 1, but it will become negative 1. So the goal here is, or the point here is, equate your divisor to 0 to get your correct C. This is also true even if your form is just like this, 2x minus 3, that's your divisor. To get the correct value of C, it's not 3, but it should be in this manner. Equate it to 0, move 3 to the other side, divide to both sides. Your correct C is 3 halves. That is the next thing you need to consider when you're doing synthetic division. And the last part here, okay, let's look at your last portion. Now, let's look at your quotient. The general concept here is that for your quotient, if you are using a dividend with x to the power of n, the highest degree of your quotient should be x to the power of n minus 1. It should not be equal to the exponent, or the exponent of your quotient should not be equal to the exponent of your dividend, nor exceeds that. It should be less than 1. That is the important thing here, because some students will also, even if they're using this as dividend, their quotient will also contain x to the power 4, and then later on that is incorrect process. So that is actually what you need to consider when you're looking at the first term of your quotient. I would like to add one more thing. I told you that's the last one, but I'm going to add one more thing. This is actually an implication of your third step. As you consider that the highest degree for your x is less than 1 of your original quotient, the last item here is what is your remainder. Okay, that is your remainder. You don't need to include it in any expressions just like x, but you simply look it as a remainder. General term of writing your quotient is you have your quotient here. If you're going to include it in one expression, you will have remainder over your divisor. Others will just simply write remainder, whatever the remainder is, but others will write the quotient plus whatever will be your remainder to be divided by your divisor, whichever it is, x minus c, or just like this. That is how you write your answer. So these are the things that you need to consider when you're going to use synthetic division. Hopefully, these are the things that you will be aware of or be cautious about when you're trying to solve the quotient of polynomials using synthetic division. So this is now the answer to the raised question. If you still have more questions regarding to this or other math concerns, please do not hesitate to contact us or drop it on the comment section below. Math in question. Think. Inquire. This is MATHinQ. Answered questions. Subscribe now.